Welcome everyone. My name is András Soros and I will talk about our state chart composition framework called Gamma. The domain of which we target with this system is the development of complex and critical systems such as railway, automotive, aerospace. And if you if you went to the IoT playground, you might also meet with us at the model-based demonstrator for smart and safe systems, where we had a distributed safety critical system under a railway table. So, for such systems, correctness is important. Our goal, our mission with this Gamma framework to support the expressive and efficient design of such systems by using composition and by providing interfaces to define services and communication. Our goal also to provide code generation for the whole system, not only for the individual components. So our solution now is based on Yakindu. You can use Yakindu to generate your own the implementation of your components, and then our framework will generate the code for the composition for the whole system together. And our main motivation is to provide high quality models by using continuous validation. So we provide various validation rules to support you during the system design, and by providing transformations to formal models so you can do formal verification. So I will just shortly introduce our approach. You can design your components by, for example, using Yakindu or your own tool, and you can generate implementation. In our case study and in our demo, we will use a traffic light system, a crossroad, where you have traffic lights, traditional traffic lights toggled by a timer, and they have 3 phases as traditional. And one more additional feature is that the police may interrupt the system and trigger a blinking yellow. And the unsafe state of the system is that the situation when both directions are green. So we have a distributed controller which are responsible for one direction. Each controller is responsible for one direction, and we had a main controller just controlling each controller. So you can use your own tools such as Yakindu state charts to define the control for your traffic lights. So this is the controller for one traffic light. You can see that you have a red, green and yellow state, and there is an interrupt region there. And there is a main controller which controls that at first the priority gets green, and after that the secondary, and also it controls the interrupts. Okay, you have the component designs and you want to put them together, so we provide a system design language, language support to put your components together, so you can instantiate your components, you can bind the interfaces to ports, and then you can connect the ports together with channels. And if you want to depict it graphically, it looks like this. We have a main controller and the priority and the secondary traffic light controller. They are put together. Okay, that's nice, but next, and you can use it for code generation. So you can, from this composite system, you can generate your code and run it on your system. But we also provide a formal language for state charts. So from the component design, we can transform to an intermediate formal language, and you can do the validation of your components. You can check for non-determinism, race conditions, and for many other kind of properties. And you can also use verification. We transform the models into the formal verification tool of UPL. And you can also generate tests for your system, unit tests for your components, and analyze if the implementation conforms to the models. And we also provide formal semantics for the system level composition, and we are able to to transform your system into a formal model, we can validate the composition of the system, and we can run system-level verification. So the Gamma framework supports the correct system design by providing validation, formal verification, and testing. And now comes a short demo. I will show you how it works. So here you can use the own code generator of Yakindu to generate the code from the state chart models. So we have the traffic light and the controller. You can use the code generator of Yakindu to generate the code, and then you can generate the code for the composite system. Actually, here is the definition of the composite system, where you can instantiate the components, the bindings, and the channels, and then and then you are able to generate the system level code from the individual components and the composition. And then you can also generate formal composite model, and then you can express your properties with the help of Gamma. You can just open the query editor, and what you want to express in this situation is that there is no situation when both traffic lights are green. So you want to say that it must always hold. There is no situation when either the priority is green, or sorry, it's not or, but it's an and also the secondary traffic light is green, and you can just push the button to verify it, and it can tell you that the condition doesn't hold. But what to do with it? We have a tool to trace the verification results back to the level of this of the code. So we get JUnit test from it, and you can run it and debug your system if it is how it goes wrong. So our framework, so you can just run this trace and evaluate it, and you can see that yes, also in the implementation you can reach this wrong state in your system design. So now you can just correct it and then run the verification again. So what I talked about is our framework to support the system level design of safety critical distributed systems. We provide formal semantics and an intermediate formal model for such systems. You can use your own code generators for the component design. It is interchangeable, so you can just, you have to, so it is easy to put another different modeling language in it. So if you have, for example, MATLAB Simulink models and Yakindu models, then you can combine them together and transform them to this intermediate formal model, and what you get is formal verification, test generation, validation, and code generation. And if you are interested, just visit this homepage. It's now an initial research prototype, and any kind of feedback is welcome. Thank you for your attention, and if you have any questions, please let me know.